Hello and welcome to this video. In this video, we will learn how to implement a three-tier architecture in AWS Management Console. So first, we will create a virtual private cloud in AWS in US East region. The VPC will have one public subnet and one private subnet in two availability zones to design high availability architecture. We will also add one NAT gateway in the public subnet. The NAT gateway will enable our web instance in the private subnet to connect to services outside our VPC. But external services cannot initiate direct connection to these instances. In this lab, we will create a NAT gateway in one availability zone to save cost. After configuring these resources, we will set up a routing table to define the network traffic flow. With these things, we can have a basic networking configuration to create a highly available and scalable web service environment. In second step, we will launch web server instance and execute user data. We will launch this instance in one of the public subnet. We will then create a custom machine image out of it. This would be required for us when we will move on to the third step. So in the third step, we will launch an application load balancer and configure a launch template, and then configure an auto scaling group to enable our web service to automatically scale out and scale in under load and ensure high availability. In the fourth step, we will create VPC security group and create RDS instance. We will then connect RDS with web app server and access RDS from EC2 instance. In the final step, we will host a static website on S3 and access our web service from the static website web page. And in the last step, we will clean up all the resources and finish this exercise. So let's get started. We will start implementing these things step by step in AWS Management Console. So I am in AWS Management Console here. And so first we have to create a VPC. So let's go and click VPC. You can click, you can have this added here as favorite also. Otherwise, if you don't see this here, you can just type VPC here in the search bar and it will show up here. If you want to save this as favorite, you can click on the star and the VPC will be added here on the bar as save as favorite for you. So let's click on VPC, and in the VPC you can see here the VPC dashboard, like it's just showing like one VPC, which is the default VPC created for my account. So here what we have to do is we have to create a custom VPC. So click on create VPC, and once you click on that, you will see two options, VPC only and VPC and more. We will use VPC and more so that we can design all the components and customize our VPC as per our requirements. So we can first give it a name as VPC lab, and I can keep this IPv4 CIDR block as it is default, whatever is showing up here. I won't change that. If you want, you can change your CIDR block for your VPC. I don't want IPv6 CIDR block for this exercise, so I'll keep this as default. Tenancy is also default. Now, as I shown you in the slides, that we need two availability zones in the VPC, and this VPC we are creating in North Virginia region, which is US East. So just click on here at two availability zones. We can customize the selection of availability zones also. So if you open this up, we have 6 availability zones in North Virginia region, and you can select whichever you want. I will keep US East 1A and US East 1B. Then we need two public subnets, in one in each availability zone. So click 2 here. For private subnet, we need 2 also. So you can keep it at 2. If you want, you can customize your subnet CIDR ranges, but I just want to keep the default. If you want to change, you can change these settings over here. Now we need a NAT gateway for our instances launched in the private subnet to make connection with internet. So we will have like one NAT gateway in the one of the public subnet, and just want to tell you that this would incur some cost. So to keep the cost at low, we will just use one NAT gateway in one public subnet. We don't need VPC endpoint for this exercise, so I'll just keep as none. In case if you want to have a VPC endpoint for S3, you can have the S3 gateway. This would allow you to connect to the S3 within your VPC. Then we can keep DNS options enabled, DNS host name and DNS resolution, and we can just click on the create VPC. So this will create all the VPC components. You can see it's creating the VPC and then creating the subnets and attaching the internet gateway to the VPC. Now creating the route table, associating those route table with the subnets, and then it's creating a elastic IP for the NAT gateway. And right now it's just waiting for NAT gateway to activate. So once the NAT is activated, it will move on to the other things. I'll pause the video right now because this would take some time. So as soon as this is done, we can move on to the next steps. Okay, so our VPC is created. Everything is showing here as created. Let's go and check our VPC. So the status is available. We have DNS host name and DNS resolution showing as enabled. And we can go to subnets. You can see that all the subnets that we configured are available, 2 private and 2 public subnets. We have a route table created, private route table and a public route table. And if you want, we can go and check the route table. The private route table has a local route and a route to internet via NAT gateway. And if we go back and check our public route table, we have a local route within the VPC, and then we have the public route from the internet gateway. So this is looking good, and internet gateway is also showing up here. And we have one elastic IP which is associated with our NAT. This is our NAT, which is also showing here as available. So I think the VPC is ready. All our networking resources which we need to start with our web service implementations is available for us, and we can go ahead with the second step. So if I show you here slide, so we have our VPC which has 2 availability zones and 1 public subnet and 1 private subnet. In each of these availability zones, we have our public route table and private route table, internet gateway and NAT gateway. So everything which is shown here is available for us. So now we can move on to second step, where we have to launch an instance in public subnet, and we will add some user data at the launch time so that we can have our custom AMI created out of this instance. Once we have our custom AMI, we will use that AMI to create the launch template for our auto scaling group. Okay, so let's move on to the second step. Okay, so I am on EC2 dashboard. Here you can see launched instance. Click on that and then just give a name to your instance, and you can choose the application and OS images from here. So we will go with Amazon Linux and go with the default option. Don't change anything here. For instance type, you can select T2 micro, which is free tier eligible. For key pair, just go with proceed without key pair. We don't need the key pair. We will try to connect to our instance using session manager. For that, we will create instance profile, and then in that instance profile role, we will add a SSM policy so that EC2 instance can assume that role, and then we can connect to our instance with session manager. For network settings, just click edit and select the VPC which we have created, VPC lab, and you can choose any of the public subnet for this instance, and select auto assign IP enable. And then for security group, we will create a security group for this instance, and we will create 2 inbound security rules, one for SSH and the another one is for the HTTP traffic. So select type as HTTP and select here anywhere. You can choose my IP also if you don't want anyone else to connect to this instance. Anyway, we will going to terminate this instance as soon as it's ready and tested. We will create image out of it. So for testing, I mean, you can go with anywhere. For storage, just go with the default options, and in the advanced details, we have an option for IAM instance profile. So let's create IAM instance profile. Click on that and then it will open up the IAM console. So here click on this create role option and then choose AWS service. We are creating this role for EC2 instance. So click on AWS service, and then for use case we can select EC2 as the service, and these are the use case available for us. So for our use cases, we want our EC2, so you can select EC2 role for AWS system manager here and then click next, and then you will see a policy is automatically available here, which is AWS managed policy. Again, you can click next and just give it a role name here. I'll copy this so that I can select it later on. and rest all is okay. This is the trust policy which will allow EC2 to assume this role, and this is the permission policy. And then here click on create role. So the role is ready. We can go and select it here. We can see EC2 instance profile role is available here. Now go back to the EC2 dashboard, and here just click on this refresh icon, and then we should be able to see this EC2 instance profile role which we have just created. Select that, and rest all you can just keep default. We don't have to change anything here. We just want to add one more thing, user data. So for user data we have to just provide like what are the things which we want to install on the instance, and the application code. I will add this user data in GitHub, and I'll provide a repo link in the description, so you can get this from there. Just copy that user data from the repo and paste it here, and let's go through this, what exactly is happening here. So it's installing the lamp stack here, and then it's starting the web server the HTTP server, and then it's installing the web pages for our lab. So here, like if you see this link, this is the place from where we are pulling the application code and adding that in our instance. And then we are installing the AWS SDK for PHP, and then just updating the existing package. So this is our user data. We will now launch the instance, and we will verify that everything is installed correctly. So you can click on launch instance now. Okay, so we have just launched the instance. Let's go back here and see what's happening. So you can see the new instance that we have just launched is currently in pending state. So once it will be available and running, then we can go and check the instance in the web browser. We have already added an inbound security rule for HTTP access from anywhere, so we should be able to access this instance from browser. So let's click on this and see what we have here. So on the details you can see we have a public IPv4 address for this instance because we launched this instance in the public subnet. We also have associated private IP address, and we also have the DNS, public IPv4 DNS for this instance. In the security you will see the security group which we had created for this instance with two rules, one for SSH and one for HTTP. And in networking you will see the VPC information and availability zone and all that information which was also available in the details tab. Storage is what we had selected default, so there's a EBS volume of 8 gig size is attached to this instance, and currently there's a status checks going on. The system status check and the instance status check is going on. Let's refresh this and see. Okay, so the instance is now showing in running state. So let's go on details and copy public IP address, and I'll go ahead and just paste this public IP address in the browser and try to access the application. Okay, so we can see the application that we have installed on the instance is available, and you can see the instance ID, and it is also showing the availability zone where we have launched this instance. There are two tabs here, load test and RDS. This we will test later on when we will configure the auto scaling group and database. This is for that testing. So for load testing, when we will click that, it will programmatically add load on the instances, and then auto scaling group will be notified that the instances are running short of CPU, and then auto scaling group will try to scale the application with new instances. So when we will configure the auto scaling group, that time we will configure like what would be the maximum size we need, like how many instances we need in each availability zone. So those things we will do in next steps, but yeah, as of now we can see that the instance is up and running correctly, and it's ready for us, and now we can create image from this instance, and then we can terminate this instance because we don't need this. We just want the image, and that's why we have created this instance. So go back to the instance, and we will create image from this instance. So click on this instance here like this, and go to action button here. In the action button we have like multiple options. You can connect to the instance. Let's go and see if we can connect to the instance via session manager. So here session manager tab, and you can see that it's showing we can connect to this instance because we added that instance profile with the policy to access this instance via session manager. So if we remove that policy, we will not be able to connect to our instance with session manager. So we can go and click connect, and then it will connect to this instance. So now you can see that we are connected here with our instance. All right, so this is done here. So let's go and create an image. Click on this instance and go back to action again, and then here there's an option image and templates. Click on that, and there's another option which says create image. So just click on create image, and just write like web server version 1. We can give same thing in the description also. The rest everything we have to keep default, and just click on create image here. So now the image creation is in progress. We can go to this images, and under AMIs we can see that image. We can see this AMI ID for this image, and if you click that, it will show the status in pending. So once this is available, we can use that image later on, but as of now this is currently in progress. So we will keep this thing running, the instance running for some time. Once the image is ready, we will go and terminate that instance. Okay, so we can see that the image status is now changed to available. So let's go ahead and terminate the instance which we launched. So we can click here and then go to instance state, and you can select option terminate instance. Okay, so now we have our custom AMI ready, and if we go back to our diagram, so this is the step that is now completed. We launched an instance in the public subnet, we added the user data, installed our application, we tested the instance, and everything was looking good. And then after that we created an image, a custom AMI, and then after that we have terminated the instance. So now this step is done. So here you can see in the next step we have to launch an application load balancer, and for subnet mapping we will use public subnet in availability zone US East 1 and US East 1B, and we will also create a target group. For the target group we will select the private subnets for the instances, and then we will configure the auto scaling group. We will also create a launch template with the help of the AMI which we have created in the last step. So this is what we have to accomplish in this step. So let's go on the AWS management console and start working on that. So first of all, we can go and create a load balancer. So here again on the EC2 dashboard, if you scroll down, you will see an option for load balancing, and click on this load balancer. As of now we don't have any load balancer, so click on load balancer, create load balancer, and there are 3 load balancers we have to choose, or we need a application load balancer for this demo. So click on create here, and just give a name to your load balancer. Just give it as web ALB, and keep the scheme as internet facing, because we want traffic coming from internet to this load balancer. Then load balancer will distribute the traffic evenly across multiple instances which we will launch in different availability zones for high availability. The IP address type should be IPv4. We don't have to change this, just keep the defaults. And again, now in mapping, choose the US East 1 and US East 1B availability zones for the load balancer, and subnet type should be public here because this is a public facing load balancer. You can see here, like if we will choose private here, it is giving us warning that the selected subnet does not have a route to an internet gateway. This means that your load balancer will not receive internet traffic, and we don't want that. We want traffic to come from internet to this load balancer, and our web servers will be running behind load balancer in the private sub. So we want the traffic to route like this. So select public here so that this ALB or application load balancer is publicly available. And then in security group, remove this default security group and click here to create a new security group for our application load balancer. So you can give this as ALGSG as a name, application load balancer security group, and then choose the VPC which we created. And now here add inbound rule. So we want internet traffic to come in to the load balancer. Internet traffic, like for internet traffic, we want only HTTP right now. So the type should be HTTP here, and everything will be auto selected. And then source, you can have custom source if you want this to be open for certain IP address or CIDR range. For this exercise, I will keep anywhere. So I think we are good with the inbound rule. For the outbound, we will keep the default, which is all traffic from ALB. Now create security group. So the application load balancer security group is ready with inbound rule for HTTP traffic and outbound rule all traffic. Now let's go back to create application load balancer page again, and here you can click on this button and then it will refresh, and now we should be able to see ALBSG security group. So select that, and in listeners and routing, so here we need to create a target group, because listener is a process that check for connection request using the port and protocol you configure. The rule that you define for listener determine how the load balancer route request to its register target. So let's go and create a target group, and this target group is of type instances because we want to place instances in our target group. And then you can choose the name as web TG, and protocol should be HTTP and port 80. Rest everything should be default. We just have to choose the correct VPC here, and health check should be default. We don't want to change anything here. Click next. Now here register target. So we don't have any instances running as of now, so we don't want to register any target as of now for this target group. This will be used by the auto scaling group. So let's create target group here, and go back to the application load balancer page and refresh this here, and should be able to select the target group. So now application load balancer will get internet traffic, and it will route that traffic to instances which are running in this particular target group. Okay, and they will listen at port 80. Rest everything should be okay. So now let's see the summary here. So we have created a web application load balancer which is internet facing and using IPv4 addressing. Security group is associated with the application load balancer, and this load balancer is running in this VPC in two availability zones, US East 1A and 1B, and these are the listeners and routing associated with the application load balancer. Now we are ready to click create load balancer. So the load balancer is currently in provisioning status, and it will be ready after some time. Now next step is we want to create a launch template for our auto scaling group. So we already created image which is required for the launch template. Now let's go here on instances, and then the third option says launch templates, and here you can click on create launch template, and just give it a name again, web server launch template. You can copy the same name and put that in description also. Okay, so now this launch template we want to use for our auto scaling group. So there is an option here, auto scaling guidance. So just click on that. Now launch template content. So we need an image here. So we can click here on my images. So you will see your image which you have created previously. So just keep that selected here, and instance type we want to launch T2 micro instances always. So with this launch template, whenever we use this launch template, we should use T2 micro instance. So for keep here, keep the default. For network settings also keep default. Now for security group, we have to create a new security group for our instances. So the instances will get inbound traffic from the load balancer, right? And we want to add that security group here for our instances. So click on create security group and just give it name like web instance ASG. Just give it ASG web instance because these are instances which will be controlled by the ASG auto scaling group. So to keep it different from the other security group which we had created for the instance which we launched in the public subnet, I just added a ASG here so that I can differentiate. Now for description also just name it same thing. Select the VPC which we created, VPC lab VPC, and then add the inbound security group. So the inbound security group should be HTTP traffic and it should be coming from the ALB, right? So select ALB and then it will give you the ALB SG security group. So this is the security group from where we would like the traffic coming to our instances. So click on that and now I think it should be ready. We don't want to change anything else here. The security group is also added for our launch template. Volume and EBS volume should be okay. We should keep that default, and then in the advanced details also everything should be fine. We just have to select the IAM instance profile which we created for our old instance. So go back here and then EC2 instance profile role, just click on that so we can able to access this instance using session manager, and then everything should be default. You can go through that if you want to. I mean, we don't have to change anything. So let's click on create launch template. Okay, so the launch template is successfully created. We can go to launch template and we can see here the launch template is ready for us, and now we can go ahead and create auto scaling group. So let's move on here, and again on the EC2 dashboard the last option is auto scaling. So click on auto scaling group, and again here click on auto scaling group. So now this is the form for the auto scaling so that we have to fill in. So let's give it a name again. Now, so auto scaling group name is web ASG launch template. So we have a launch template, web server launch template. We just created that. So select that option here. You will only see one option because we just have like one launch template. In case you have like many launch templates in your account, you might see more. Make sure that you select the correct one. So everything you can see in the launch template, we have the instance type as T2 micro. We also have a security group for our instances, and we don't have any key pair, but we have instance profile role attached to this launch template. So we will be able to access instance via session manager in case we want to. Now click next. Now here instance type requirements, keep it as it is. We don't have to change that. In network we have to select the VPC which we created, and in availability zones and subnets. So remember I showed you that the instances are running or controlled by the ASG are running in the private subnet. So let's go and select the private subnets here. So US East 1A private subnet and then US East 1B private subnet. So now we have our VPC and the two subnets, two private subnets. Okay, now we can go ahead. In load balancing, we want an existing load balancer which we have created. Choose here attached to an existing load balancer, and then here choose from load balancer target groups. So for the load balancer we created a target group also. So select that target group. Rest all is default here. Health checks should be default. We don't have to change anything, and then click next. And here is what we have to configure. So this is the group size. Right now it is showing the default option with desired capacity 1, minimum capacity 1, and maximum capacity 1. For our auto scaling group we want at least 2 instances running in each availability zone, and for maximum capacity, like in case of load on the application, we want to change the size to 4. Okay, so this is what we are configuring. So we will see when we will apply the load, and like we'll see whether auto scaling group triggers and increases our group size or not. So that testing we will do later on. Now scaling policies. So we want to apply load, and then we want to check the available CPU percentage. So for that, like, we can click on this target tracking scaling policy, and then we have multiple metric here which we can choose and test on these things. So average CPU utilization is something which we can use, where we can keep this as 50 default value. So if the CPU available CPU or the utilized CPU value goes beyond 50%, and if the instance don't have 50% CPU, less than 50% CPU left, then the auto scaling group will be notified. Just keep it default and click on next. We don't want to add any notification. If you want, you can add notification SNS topic, so you will get email in case if there is any change in the auto scaling. If your application is scaling in or scaling out, you will get all the notifications. We can see these activities on here in our AWS management console also. Now click next, and then again click next, and then let's review. We have web ASG. With our web ASG auto scaling group, we are using the launch template which we created. We are using the private subnets in our VPC, and we are using the load balancer which we had created, and that with the target group, and then this group size, desired capacity is 2, minimum capacity is 2, and maximum capacity is 4, and we are tracking our targets based on the CPU utilization. Okay, so now we are ready, and click on create auto scaling group. All right, so here you can see in the status it's saying updating capacity. So now the auto scaling group is created, it's activated, and now it is checking whether we have desired capacity in our availability zones in the subnets where we have configured. So based on that, it is checking that, and then if you go here in the activity, it is now launching the instances. So you can see that increasing capacity from 0 to 2, because we had no instances running, so it is changing the capacity from 0 to 2. So in some time these instances will be available up and running in both the availability zones in the private subnet. Okay, so now we can see our instances are showing status successful. So they have like auto scaling group just launched 2 instances in both availability zones. So we can go to EC2, and here we can see that instances running, number of instances running showing 2. Let's click here and see whether we have any public IPv4 address. So you can see that this instance don't have a public IPv4 address because we launched this instance in the private subnet. So this is not available to anyone outside this VPC. It's a internal instance private to the VPC. No one can access this instance from outside the VPC. Same way, if we check the other instance, we should not see the public IPv4 address, right? Okay, so our instances are running, and let's go to auto scaling group one more time, and so the activities is showing here. It's successfully increased the capacity from 0 to 2. Here in the automatic scaling, I want to show you this, that we are using the target tracking policy as per our configuration. And if you read this, scaling policies resize your auto scaling group to meet changes in demand. With reactive dynamic scaling policies, you can track specific CloudWatch metric and take action when CloudWatch alarm threshold is met. So I think this is ready. Step 2 is ready, and let's go and check whether we are able to access our application or not. Okay, let's go to EC2 dashboard again, and then I need application load balancer DNS. So click on application load balancer, and then here is the load balancer DNS. You can copy that and just paste that here in the browser. Okay, so now you can see in this instance this connection should change to other instance. Okay, now you can see that we are now connected in US East 1B with another instance which is launched in that region, in that availability zone. So yeah, this is showing that we are able to connect to our application with application load balancer, and this application is running and like controlled with the auto scaling group. So let's try to check this load test. This load test and the logic behind that is there in the application which we are running here. Once I'll click that, it will put some load on the application, and then you will see that the CPU utilization will change here. The current CPU load will change from 0% to like 100% or something like that. Let's do that. So if I click load, so here you can see the load.php. There's some code written over here which is doing this. So generating CPU load, auto refresh in 5 seconds. So current CPU load is 100%. So now we are putting some load on the application, and then this load is getting auto refresh in 5 seconds. In the auto scaling group, and go to monitoring, and then EC2, and let's see this CPU utilization percent. So it is showing 17 here. So now we can see that there's a CPU percentage of 17.2 currently showing up here. Let me go here and click it again. All right, so this CPU utilization is slowly increasing, and it is applying load after every 5 seconds. Current CPU load 100% applied, so it's increasing the load on the CPU, and slowly we will see this percent will increase and it will reach to 100%. Okay, so here you can see that after applying the load, the auto scaling group increased the capacity from 2 to 4, and now when I stopped applying the load, the ASG is again reducing the capacity from 4 to 3 and then 3 to 1. So here you can see the connection draining in progress, and if you go and check the instances, we have 4 instances running, and after some time we will have only 2 instances running in the auto scaling group. So this is how the auto scaling scales in and out when there's a load on the application based on the desired capacity and the maximum capacity. And because we have the minimum capacity of 2, so we will in the end we will have only 2 instances running in the auto scaling group. So here you can see it again, it's still doing this. So after some time we will again review this and check whether that capacity reduces or not. So now you can see that the capacity is now reduced again to 2, and auto scaling group terminated the 2 extra instances which was launched by the auto scaling group when there was load on the application. So here you can see that it's now completed, and if we go back to number of instances, only 2 instances should be running and the other 2 are now in terminated status. So this proves that auto scaling group is configured correctly, and our application can scale in and out based on the load. If we go back to this slide again, so we have successfully implemented step 2. So we have a architecture where we have a VPC with internet gateway and availability zones with 2 public and 2 private subnets, where we have an auto scaling group configured for the private subnet and an application load balancer in the public subnet. So this whole architecture is currently available in AWS. So in the third step, we have to launch a DB instance in one of the private subnet. Here you can see there's a new Amazon Aurora primary DB instance in US East 1A private subnet, and then in US East 1B we have a read replica of our DB. So in the architecture, like I'm showing Amazon Aurora, but I will be using MySQL, and I will not create a read replica in US East 1B because I will be using free tier, and in free tier we can create only single DB instance in the availability zone, in one of the availability zone. But if you want, you can go ahead and create a read replica also. When we will create RDS, it gives us 3 templates, like 1 for production, 1 for test and dev, and like 1 for free tier. So if you go with production template, you will be able to deploy a multi-AZ RDS instance. But if you want to keep cost low for this hands-on exercise, I would recommend to just go with 1 DB instance, because we just have to make sure that we are able to connect to this DB instance with our web server instance. So, and this is just a hands-on exercise to make sure that we can deploy this whole architecture in AWS. We don't want to going to test any read heavy loads or transactions for our database. So we don't really need that, but I'll show you how you can create read replica and multi-agent deployment also. But when I will actually create an instance, I will go with the free tier option. So that's it here. Let's go to AWS Management Console and then we will start creating the RDS DB instance. Okay, so let's start with RDS, and we can search RDS here and then click on RDS. So to create RDS instance, we first have to create the DB subnet group. So here you can see the option subnet group. You can click here, click on DB subnet group and just give a name here, DB subnet group. You can copy this in description also, and then choose the VPC lab, and then select two private subnets in US East 1A and 1B. And in US East 1A, 10.0.128.0/20 is the CID range for one of the private subnet, and then in US East 1B, 10.0.144.0/20 is the CID range for the subnet, private subnet. If you don't know that information, you can go to your VPC, and here you can go to subnets and just arrange that here, and then you can see for private subnet the CID range is 128.0, and the others private subnet in US East 1B it's 144.0. So you can confirm the information here on the VPC dashboard also under subnets. So now we have selected two private subnets and click on create. So our DB subnet group is ready. This is what we will need when we will create the DB instance. And the second thing which we need is to also create a security group, a VPC security group for the database instance. So for that, you can go to VPC console again, and here under security, you can click on this security groups. It will show all the other security groups, like this one for the ALB, and this one is for the instances running with the auto scaling group. So click on create security group here and name this as DBSG. You can give the same name for the description also. And now here you have to select the VPC lab, and then here the type of the inbound connection should be MySQL, and the port will be 3306, and the source will be custom, and this source will be our instances running in the auto scaling group. So type ASG here and it will show you the security group for the web instance running in auto scaling group. So select that. So this will be our inbound rule for the DB, and outbound rule you can keep it as default, and then click on create security group. So our DB security group is ready, our DB subnet group is ready. Now we can go to RDS dashboard and click on create database. So here we have two options. We have standard create and easy create. Go with standard create option and then choose the engine option here. So I am choosing MySQL. MySQL is a open source database, and it will be MySQL community version, and then the engine version you can select from here. I will select 5.7.43. You can select any version. MySQL engine version earlier than 8.0.17 don't support newest M6G or R6G generation instances. So if you are using these instances for your RDS database cluster, then the MySQL engine should be at least equals to 8.0.17. In our case, we are not going to use these instances. For this exercise, 5.7.43 is also good. Now in templates, we have three options: production, dev test, and free tier. And if we choose production, then we will get some more options, like for availability and durability, we can launch multi-AZ DB instances. So it will create a primary DB instance and a standby DB instance in different availability zone. This provide high availability and data redundancy. The standby instance does not support connection for read workload. So it will be just a standby instance. It will not be used by the application. It will be available for us in case of any failure. The DB instance will fail over to this standby, and then standby can be converted into a primary DB instance. So for multi-AZ deployment, this is the configuration. For dev test, it will just give you a single DB instance instance option, it will create a single DB instance with no standby DB, and with free tier we will not get this option. So with free tier also it will be like single DB instance that we will create in one of the availability zone. So select that free tier option, and then here give DB instance identifier name as RDS cluster. For credentials you can give any user ID and password. I'm giving AWS user as user ID for the DB, and this manage master credential in AWS secret manager, you can click that, then it will create the secret in secret manager for this DB. We will do this exercise later, so I'm not selecting this right now. And for the password I'm giving DB password. Instance configuration, so go with this default T3 micro instance. And storage type, again we will go with the default. Connectivity, again we will go with default. We don't want to connect EC2 instance to the database right now, we will do this later. And network type will be IPv4, and then here we have to select the VPC which we have created. Once you will select that, then it will show the DB subnet group also which we have created before. And again here we don't have to change anything, we go with the default option. We don't want RDS to be publicly accessible, so keep it no here. And then in VP security group we can click on choose existing, because we have already created a VP security group for the DB instance. You can remove the default and then select the one which we have created, which is DBSG. Now in the availability zone, if you want to put your DB instance in any availability zone, you can select that. So I will select US East 1, and then RDS proxy I don't, we can just keep with the default. Database authentication, also password authentication, go with the default. Monitoring, if you want, you click that enable enhance monitoring. Then here in additional configuration you can open that and give a initial database name. I will give immersion day, and just keep everything default here. If you want to take backups, you can enable automated backups. I will disable this. And for encryption you can enable encryption. It will use the default AWS RDS KMS key. And for maintenance, enable auto mirror version upgrade. You can keep this as default, and then it will show you the estimated monthly cost for this RDS database cluster. And then finally just click on create database. So the RDS database is currently in creating status. After some time the database will be available, and we will review some of the configuration details, and we'll also see how to create a read replica from RDS cluster. If you select this and click here, we currently don't have a DB instance endpoint, and the port information is also not available. Once this will be done and it will show available, then we will have a DB instance endpoint available here. Okay, so after some time you can see here the status is now available. The RDS cluster is available for us, and you can see that the size is DB T3 micro, and it's not a multi-AZ DB. So the cluster is ready. So in our architecture diagram I have shown you that we have a in DB subnet in one of the private subnet. In the other availability zone we have a read replica. As I told you that I'm not going to add that, but I can show you how to create a read replica from your primary DB instance. So let's go to AWS management console, and with the help of this RDS cluster, the primary DB instance, we can click here, and then we can go to actions, and here we have an option for create read replica. Or even you can create Aurora read replica also, and you can also create a blue-green deployment. So we will go with this option right now, create a read replica. And if you create read replica, it will use the source as RDS cluster, the DB instance identifier that we have created before, which is our primary DB instance. And then you can name this one as RDS Read Replica. This is the DB instance identifier for the read replica. And then go with the default instance configuration. It's same as DBT3 micro. And then AWS region, we will keep the DB read replica in the same region as per the architecture we have seen before. And for the storage also go with the default. For availability we can have multi-AZ DB instance also, but for this one we will select a single DB instance. Then for connectivity, IPv4 keep the default, and then the DB subnet group, whatever we had created before, we will keep the same DB subnet group, and it is also not publicly accessible, this read replica. And then within the VPC we already created the DB security group, so keep that selected. And for availability zone we can choose now US East 1B. So in US East 1A we have our primary DB instance running, and then US East 1B we are creating a read replica of that same DB. Now rest of the information we just have to keep default, and the encryption is automatically enabled on this read replica. And then if you want, you can enable auto mirror version upgrades, and if you want to have delete protection for this read replica, you can click that here. If you don't want that, then you can keep it default, and then just click here to create the replica for your database. So this is how you can create a read replica in different availability zone in a private subnet. So as I said, I am not going to create that. I just need like one DB instance, and now we will like to connect our DB instance with our instances. Let's go to EC2 and copy our load balancer DNS, and let's try to access our application. So copy this DNS name and put this on the browser, and we should be able to connect to our application. So here we can see right now we are accessing our application from US East 1A, and one of the instances is connected. Now if I click on RDS here, it is showing address book, but it is saying error access denied exception. Now why this is happening? Because EC2 instance which is running our application, and in the application we are trying to connect to MySQL database, and for that we are trying to read the secrets from the secret manager. This is what application code, I mean I can show you that application code also. Let me bring that here. So this is the RDS configuration file, and this is the part of the application code. You can check the application code in the GitHub repository. I have given the link, so you can go and download that zip file, and then you can extract and see like what exactly happening in the application. So here this is one of the file where it's trying to get the secrets from the secrets manager for the DB instance. So here you can see that in the code it is trying to retrieve the host name, the database name, username, and the password from the secret manager. So right now that's what is happening. Like when we are trying to access RDS, it is trying to go and read the secret from the secret manager, but the EC2 instance right now do not have access to the secret manager. So we created the instance profile role, and in the instance profile role we just added one permission, which is for connecting the EC2 instance with the session manager. We did not add any permission for EC2 instance to connect to the secret manager. So to allow our application to connect to RDS, we will first have to store the secret in the secret manager, and then we will have to add a policy or permission policy to the instance profile to read the secret from the secret manager. So these are the two steps which we will need to do to connect our web server to the database. So let's go and first create a secret in the secret manager for the DB. Okay, so I can go back here in the AWS management console, and here I can search for secret manager. Go to secret manager, and you can go and click here store a secret. So once you will go here, it will give you few options like credentials for Amazon RDS database or credentials for Amazon document DB database. So if you select this credential for Amazon RDS database, and then here you can select the database for which you are creating the secret. You just have to click next here and give your secret a name. So now this application which I showed you here, and if I can show you the application code, the name of the secret that it will go and try to read is my secret. See here, the secret name this application is trying to get from the my secret manager is my secret. So your secret name should match this name. So and go back to the AWS, and here paste my secret, and then same for the description. And then if you want to replicate secret, this is optional, just keep it default and click next. I already have this secret created in my AWS secret manager, so I will get an error that it already exists. A secret with this name already exists. But for you can just go ahead and click next and then create this secret. Once you have this secret created, then you will see my secret created over here, and if you click that, it will show you the secret details. I have marked this secret for deletion, but I can say cancel deletion here, and you can see the details for the secret manager. So the secret value you can retrieve from here by clicking the secret values, but this secret is now available and I can use it in my application. The application can now read my secret from the secret manager. Now before it can read, we have to provide our instance permission to read the secret from the secret manager. So for that we can go to IAM and we can create a policy. So we will create a new policy where we will just provide access to read the secrets from the secret manager, nothing else. So you can choose the service secret manager, and now in the secret manager, what we just want to provide read access. So get secret value, that is what we want to provide our EC2 instance. So select get secret value. And okay, and for resources, you can give all resources in secret manager, all the secrets. The EC2 instance will be able to read all the secrets. If you want to give any specific resources, then you will have to provide those specific ARNs here. So for example, if I go back here to my secret, and if I just want to provide access to this particular secret, then I can copy this secret ARN and I can go back here and add that ARN. So here you can see that I have added the resource ARN, and these other things are automatically populated. So the region selected is US East 1, and my secret name is my secret, and then just add ARN. So that way you can provide specific secret access to your EC2 instance, or if you want, you can just click on all also. So EC2 instance will be able to read all secrets from your secret manager. Now click next here, and then just give a policy name here, and then just click create policy. So we have created this policy EC2 read access to secret manager. Now we have this policy ready. We can go to roles and we can search for the EC2 instance profile role that we had created. So EC2 instance profile role new, this was the profile role I created for the EC2 instance. So click on that, and here you can see that we just have one policy, permission policy attached to it. Now here we can go to add permission and then attach a policy, search the policy which we just have created for the secret manager access, read access, click that and add permission policy. So now our EC2 instance can read the secrets from the secret manager. We have secrets available in the secret manager for our DB instance. So now our application should be able to create a connection with the RDS. Let's go back to the application and now try to access RDS. Okay, so here you can see that now we are able to access our database, and it is showing the default record created by the application. Now we can add new records also here, like that. So we can add new records, we can remove records, and if we want to load the database again with the initial data, we can click here and then it will load the RDS with the initial data. Now you can see that loaded with the initial data again. So I think everything is looking good. We can able to access our application. We have connection to the RDS database instance running in the private subnet in one of the availability zone. So now we can come here and we can see that we are able to connect everything here till now. The next step is basically to create an S3 bucket and then add index.html and any other media that you want to add for your static website. And then we will host a static website from S3 bucket. We will provide a link to our application from that index.html page. We will be able to access the application from the static website. So let's go and create S3 bucket, add the index.html, and then we will enable the website hosting for that S3 bucket. So I'm in AWS Management Console again. Here I can go to S3. You can also search S3 in the search bar, and then we will create a bucket here and just give it a name like a random name, so that the bucket name should be unique, otherwise it will throw error that the bucket name already exists. So whatever name you are giving, make sure that it's a unique name here. And then we want to create this S3 bucket in US East North Virginia region, and keep everything default and just create a bucket. So our bucket is ready, emergent day bucket. And now we have to add the index.html and any other media that we want to add for our static website. So I have created this index.html. It's a basic HTML file. So here you can see that I'm adding a image and I have to provide the source of that image here. And then on click, I want redirect to the application load balancer URL. So I go here, click on upload, add files, and then here I have created a folder, and then I'll upload this AWS PNG. So now I go here, click on the object, and this is the object URL that we have to copy and update that in our HTML file. Okay, now the second thing which we need is the load balancer URL. So when someone will click on this image, it will redirect user to the load balancer, which is where we are running our application. So we can access our application via load balancer. So let's go there and get the load balancer URL. So this is our load balancer, and here is DNS name for the load balancer. Go here, save this file, and then go to your S3 bucket again, and here we can now upload the index.html file. All right, okay, so now in our bucket we have the index.html and media for our static website. Now go to properties of the bucket and scroll down at the bottom. You will see option for static website hosting. So right now it is disabled, so let's click add it and enable static website hosting. And this here we have to provide the index.html page. If you have any error.html, you can add that here and just save change. As soon as you will save change and scroll back here, it will show you that static website hosting is now enabled and hosting type is bucket hosting, and this is your URL for the hosting website. So you can copy that, and now you can come over here in the browser, you can paste it here, but as soon as you will try to access it, it will say access denied. So here it is showing access denied. We cannot access this URL because if you go here in permission in the S3 bucket, we have block public access, which is on. So there are multiple options. We can we can first go and edit this and remove this block all public access, and then we can create a bucket policy to provide public access to the bucket objects, or we can provide public access to our objects using bucket ACLs. So here in this exercise, we are just going to follow the the basic thing and simple thing, which is to enable the bucket ACLs and then make our object public, so that those things can be available publicly when someone will use our website URL. So first of all, I will go and remove this block all public access and then save the change. Let's confirm this here. And now if you scroll down, you can create a bucket policy and make your object public using a bucket policy. And the other option is to control with the help of ACLs. Okay. So what we want here is we want to change this here, edit object ownership, ACL disabled right now on this bucket. So we will enable the ACLs, and then we can keep the bucket owner preferred option selected and then save changes. I have to acknowledge this. Okay, now we have enabled the bucket ACLs. We can make our objects public. So to do that, what you can do is you can click on the object, go to action, and then here there's an option called make public using ACL, and then you can click that and make this public. Same way, we can go back and make this index.html public like this. So now both the objects in this bucket are publicly accessible with the help of bucket ACLs. So now if we go back here and try to access our website, we should be able to see that. So now you can see that the static website is available, and when we click on the image, it should redirect me to the application load balancer URL. Okay, so now it's correctly routing us to the application load balancer URL, and here we can access our application. If we click on RDS, we should be able to see our address book. We can add new contacts, we can remove new old contacts, and we can load with initial data also. So everything is working fine. This load testing we already performed. So based on this, I think we have completed everything. So now if we see our final architecture, we have everything in place. We have hosted a static website, and we have provided link to our application load balancer URL. From the application load balancer URL, we can access the web instances, and then we can also access our database from our web instances. So this is how you implement a 3-tier architecture in AWS using AWS Management Console. Okay, so the next step is to do the cleanup. So for cleanup, first of all, you can go ahead and delete your Amazon RDS cluster, then delete your Amazon RDS snapshot also. After that, this will take some time, and then after that you can go ahead and delete your secret from the secret manager. You can schedule it for deletion, and the minimum number of days is 7 that you can select. Then you can delete auto scaling group, then application load balancer target group, the EC2 AMIs that we have created, the snapshot which was created along with the AMI, then the launch template, NAT gateway, and then we have to release the elastic IP address associated with the NAT gateway. You can delete all the security groups, and then finally you can delete the VPC. And in the end, you can delete the S3 bucket objects and then also delete the bucket. So I'll quickly go and delete all these things. I'll just do this in fast forward mode so that you can see what I'm doing. We cannot release IP address associated with NAT unless NAT is deleted. So we have to wait till NAT is deleting. Once NAT is deleted, then we can release the elastic IP address also. So let's wait for RDS and this NAT to be deleted, and this auto scaling group also, because these three things will take some time to be deleted. So once NAT is deleted, then we can also delete the target group and the security groups and the other things. And once NAT is deleted, we will release the elastic IP, and then we will delete our VPC also. Meanwhile, what we can do, we can delete our S3 also, S3 bucket, because it's not linked with anything. So you can come here and first of all delete the objects. And once the objects are deleted, then we can go ahead and delete our bucket. All right, so bucket is also deleted. Now we are left with the NAT and RDS. So RDS is still deleting, but I can see the NAT is deleted. I can refresh this. It will be there for some time, but after some time it will be gone from here. But it is showing it's deleted. So let's go and to delete the elastic IP address. We don't have to delete, we just have to release the elastic IP. So this option, release elastic IP address, and you can release it. There's one more thing. If you want, you can keep this elastic IP address, but this cost some money. You have to pay the price for keeping the elastic IP address. So if you, let's say if you have an elastic IP address in your account, you can always go ahead and associate this elastic IP address with something else. So that's something else also you can do. But right now I don't want to keep this elastic IP, so I will release this elastic IP. Now you can see I'm able to release it. So the elastic IP is also released. So here now what we can do, we have elastic IP released, we have NAT gateway deleted. I'm just waiting for the RDS to be deleted. Once RDS is deleted, then I will also delete my VPC. I have to also delete the RDS snapshot, which was created when we created the RDS cluster. So it's still deleting. So once it's deleted, then I will delete the other things. Okay, so my RDS cluster is also deleted successfully. Now I can go to snapshot, and there are two snapshots, so I can just go select them and then delete snapshots. So my snapshots are also deleted. Okay, so let's review what we have completed so far. So we have deleted the RDS cluster, RDS snapshot. We have marked a secret for deletion. We have scheduled that. Auto scaling group is deleted, and then application load balancer is also deleted. Target group. So let's go and delete the target group from the EC2 dashboard. So let's go here in the target groups, and you can delete that. Just a FYI, like, you can keep these target groups. It will not cost you any money, but in case you want to do cleanup, you can delete them. So the target group is also deleted. Now what we have EC2 AMI, so we have deleted the EC2 AMI, and we have also cleaned up the snapshot, EC2 snapshot. So these two are done. Launch template. So let's delete the launch template from here. Delete template. Okay, so launch template is also deleted. Now we have also deleted the NAT gateway and released the elastic IP address. Security group, it's up to you. If you want to keep the security groups, you can keep it, but if you want to delete, you can delete them. So we have to delete security group like one by one, because there is a cyclic dependency between like DB security group and the ALB and this ASG web security group, and then this is dependent on this. So delete them one by one. Otherwise, like if I select everything like this and say I want to delete security group, it will show this error that one security group is associated. So it will not allow me to delete all of them together. I will have to first delete the DB and then ASG and then the ALB, like that. So So first select the DB and then delete security group. Then you can select the other one, ASG, and then delete security group. Now you can select the ALB and also delete this ALB security group. Let's refresh this. So we are left with uh, this one which we created for the instance which was launched in public subnet. So we can delete this also. So our security groups are also cleaned up. These were already present in my account previously. And now we are good to go with deleting the VPC. So go to VPC console and go to your VPC, select the VPC, go to action and then delete VPC. So it will delete all the resources like internet gateway, private, route table, public route table, subnets and everything. All right, deleting subnet, route tables, VPC. So now I think we have all cleaned up. We don't have any other resources left in our account which will cost us money. So everything is cleaned up correctly. You can review this again one more time to make sure that you have deleted everything. So once deleted, we are good. So we can. Okay, all right. So in this demo, we have seen how to implement a three-tier architecture in AWS. I hope you liked this video, and if you have any questions, you can comment down and ask me in comment section. You can follow me on Medium, and I'm sharing a lot of good articles on Medium also, so you can read them there. And if you have any questions about any of the article, you can always connect with me over LinkedIn and ask me any other questions. So thank you for watching this video. I hope you guys enjoyed it. Thank you so much. Bye.